Hello and welcome to SudoKanard. We're here to solve factor line Sudoku by Richard Stolk. This is part of his Sudoku variant series that had been on hold for quite some time. And Richard started his series again a few weeks ago, and I was not aware of that. And I have to thank a viewer for pointing out this puzzle that was requested for this video. So factor lines is a rule set that we have already seen. It was featured in Sudoku Grand Prix. It was a puzzle by John Erturan it was in 2024, I think. And the rule is not that complicated. Whenever two cells are connected by such a line, one of the digits must divide the other. So it could be a 9 here with a 3 there. That's a possibility. It could be a 1 with whatever digit here. It could be a 2 here with any even digit here. And that's all there is to it. So I put the link in the description so that you can have a go at the puzzle. And I must say I already solved this puzzle a few weeks ago. So now I have to do a fresh start. The place of interest to start this puzzle is definitely this area. Something that needs to be appreciated is that some digits, namely 5 and 7, are very constrained. 5 can only be next to a 1. We can address this. 5 can only be next to a 1. The same is true for 7. Or if we are in such a situation, we could have 7 linked to 7. Well, not in this case, because 7 is already in the region. But that's interesting. 5 couldn't be here either for a double 5, I mean, couldn't be here for the same reason. Now we must ask where 5 and 7 go in this region. You can see that none of those cells can have a 5 or a 7, so they must both be in those cells. And then what's interesting is that at least one of them here is a 5 or a 7, and the neighbor here is not a 5 or a 7, so the neighbor here can only be a 1. And now, which one is here, which one is... Are they both here, or is one of them here? This is another question. And actually, 5 or 7 here would force this to be a 1, which would be inappropriate. So 5 and 7 are both here, and this is 1. So that's for a start. Now let's think of what remains. 9 is somewhere, and 9 is also quite constrained. 9 can only be next to the 1 and the 3. So 9 could be here, or it could be here. If 9 is here, then this has to be a 3. And if 9 is here, then this has to be a 3. Now let's think of 6. 6 can only be next to 1, 2, and 3. And the other part, so what are the options? Let's think about it this way. So let's just do a duplicate of this in another region. So let's just disregard the lines that are in here. and just clone what we already have. Oh, this is annoying. All right, I'll clone it anyway. So so this is one scenario. And where does 6 go? It could be, oh, actually next to the 3, it will only be 6. Actually, that's correct. The next neighbor of 3 can only be the 6. And we see, because of that, that 6 won't work here. So 9 and 3 are finally here. This is 6, and now the only remaining neighbor for 6 is 2. And those are 4 and 8 in any order. So that is a correct beginning. And we must think, where do we go from here? The fact that 1 is here is interesting because regarding those two 7s, there must be a 7 up there. But a 7 here would require this to be a 1, and the other way around is true as well. So 7 must go there. What can we have here? So those two are really in a relation of division. And knowing that 3 is not here and 1 is not there, they have to be even digits. They could be 4, 8. They could be 2 with another even digit. So one option is 4 and 8. 8, I said. And the other possibility is, because of this, to have a 2 there, in which case this is any even digit. But now, 6 here would require this to be a 1, a 2, or a 3, and none of those are available. So this must be from 4 and 8. So 2 and 1 are not available, so this is from 4, 8. And now this is not 4 or 8, so this has to be a 1 or a 2. This now can be a 1. It can't be the 4. So it can be 1. With 8, it could also be a 2. With 2, it could also be a 6 or an 8. So that's a lot of options. I agree with you. And then what we need to understand is that with a 1 here, this could be any digit. Well, obviously, none of those digits, but any other digits, which is not that many. It could only be 4, 5, 8, or 9. Well, let's just pencil mark this. That's not nice. Let's have a look at this. Because of this one, this line is very constrained. This must have 2 neighbors. And this is not 3 or 6. It couldn't be 9, because 9 would be surrounded by 1 and 3, and 1 is not available. So this has to be an even number, even digit, and it's not 6, so it has to be one of those. 8 would be surrounded by 4 and 2, which seems to work. 4 would be surrounded by 8 and 2, which seems to work. And 2 would have here 4 or 8, and there any even digit. So what remains after all I've said is that those are even digits. And namely, this is 4 or 8, which means that 4 and 8 are no longer options in here because of this 4-8 pair. And that because of that, this has to be a 1. And this is also an even digit, but I think that all of them are still possible at this point. All right. Here we have the second 5 or 9 somewhere, and we have the missing even digit. We know that 6 is one of those because of that. Let's have a look at this, I think. This is not surrounded by any 1. So this is something that can have 2 neighbors different than 1, different other than 1. So an even digit would work. Or 3 could work. 3 could be surrounded. 3 could be surrounded by 9 and 6. So this is not that interesting. Those two, no, that doesn't seem to be so promising. What about this? This here is not a 2 and has 2 neighbors, so 1 is the easiest candidate. Could it be a 3? This again has doesn't have 1 as a neighbor, so it could be an even digit, namely 4 or 8. And this could work with 2 here. Oh, we must appreciate the fact that those digits here are from 3, 5, 7, 9. None of those would work with 4 or 8. Six is not available, so this is either 1 or it could still be 3. 3 with a 9 here would work. And that's the only option. Or could it be a 9? No, 9 would be surrounded by 3 and 1. So only 1 and 3. The issue with this kind of variant is that there's always the chance that you overlook a possibility. This is why this kind of variant is always scary when you have a restricted time in Sudoku Grand Prix. All right, so let's continue. So this, knowing that this can be a 1, and I suspect that it is a 1, this could be basically anything. What about those two? So one of them divides the other. 2 is not available. This is not a 1. This could still be a 1. It doesn't include a 6. We could still have 4 and 8. If 1 is not in there, it's not 3 and 9. If 1 is not in there, then this is 4, 8. But we could also have the 1 here, or could we? I'm actually wondering if 3 could really work here. 3 would go with 9 here, but nothing would work here. So no, 3 is not an option. That has to be a 1, so that those two can only be 4, 8. They can't be 3 and 9. They have to be 4 and 8. Now this can't be a 4. It can still be 1, 2, or 8. If this is 1, then we have basically anything here. If this is 2 or 8, then this is also 2 or 8. In which case this can be 4, 8, or even 1. This is not interesting. Oh, this is next to that. So it's either an even digit or the 3 with the 6 here. That's a lot of options to consider. Well, this is more promising. 1 here tells us that this has to be one of those numbers. I should say 1, 3, and 6 tells us that this is either a repeated number from there or a 9 next to the 3. So in all scenarios, this has to be from 5, 7, 9. And now that this is not a 3, well, next to 5 or 7, this is a 1, and next to the 9, it can now only be a 1. And this is 2. Let's consider the fact that the remaining digits here are 3, 5, 6, and 7. And this can't be a 5, this can't be 6 or 7. So that this must be next to this and that. This is not a 1, so this can only be a 3 after all. And next to 3 and this can only be a 6. Which means that this is neither 4 nor 8. This is 7, this is 5, this is 6. Two and 6 both work. 6 here would put a 2 there. 2 there would put 4 and 8. All right. So now this is 1. This can really be anything. Those are from 4, 8, and 9. Let's do some Sudoku. Those are from 2, 4, 8, 9. I think I pronounced 7 instead of 8. But this is really not unusual on my part. Now let's ponder. I probably already addressed this. The fact that this has to be either a 3, going with 9, or an even digit. This hasn't changed in the slightest. And it's still not that useful. What about this column? In this column, we still need to place 3, 5, 7, and 9. This is not 7. This is not 5. So I tend to be on the heavy side of pencil marking, but sometimes with complicated variants, you have to do what you have to do. All right, 5 will go with a 1. 3 could still go with a 6. 9 could still go with a 3. So 3 options. This row already has 5 digits located, so the remaining digits are 5, 6, 7, 9. 5, 6, 7, 9. There's a 6 here, so 5, 7, 9 here. 5, 7, 9, and 4 options. Well, we need a 3 somewhere in here. There's an 8 somewhere in here. Not sure what to do with all of this. Pencil marking is starting to be a little cluttered. I'm not sure where to look. This can be any digit, so perhaps something. Oh yes, the neighbors of 6 are 2, 1, 2, and 3. None of them is available for that, so that is not a 6. The only place for 6 in this region is here. That's not a 6. Now what about 3? Well, 1 can still have any neighbor, but 3 could only have 9 as a neighbor here. Oh, but 3 with a 9 here would make this a 5, and 5 can't be neighbor to the 3. Yes, if I put 3 here, then this is 9, and there's no valid option here. So that has to be a 1, which is interesting now, because this is not 1. So this now has to be an even digit next to 2 and 8, so it has to be 2 or 8. And this is 4, and this is 8. This is not so spectacular. So this can now be anything next to our beloved 1. This row still needs 2, 4, 5, 6. So this 2, 4, 5, 6. So this is a 5. And this here can no longer be a 5 next to this. It could still be 7 or 7 with a 7 and 9 with 3 or 9. So this row still needs 2, 6, and 4. So this is from 2 and 4. 2, 4, 6. So we have located all even digits. Those are 3, 5, and 9. So this is from 3 and 9. Still 3 options in here. This column still needs 3, 7, and 9. We have a 3, 7, 9 triple, and the second 2 or 4 is here, in this area. Sudoku tells me that this is 5, and this is not. I still need a 1 somewhere in here. 1, 3, 7, 9. So this is from 1, 3, and 9. 4 options here. I'm not pencil marking that. 8 is somewhere in here. don't think I can do anything with that. 1, 2, 8, 9. 1, 2, 3, 8, 9. So this is from 2, 8, 9. I'm saying that 6 here would make this a 2, and 2 would make this a 2, so that is never a 2. This row needs 2, 4, 8, 9. And I don't see anything to deduce from that. Oh, inside this region 3 is here, so that's not a 3. That's not so useful. That's not the most spectacular deduction I could make. I really don't know where to look next. This could still be anything. Oh, there's a 2, 8, 9 triple here, so that's not a 9, and this is actually 1 or 3. Perhaps that's interesting. Oh, 9 here would come with a 3. But then those two would be both 7s, so that doesn't work. This is finally an even digit. 1 is not available. This has to be an even digit. 2, 4, 6, 8, and this is not a 3. So 3 in the column is here. And this is 9. So now one of them here is a 9, which means that this is 7, this is 5. And this is 9, this is 5, this is 9. Not 9 here, so that this is 9. This here is a 7. This 7 forces this to be a 7. That's a 3. This is now 7, this is 3, this is 1, this is 3. So the magic is happening. That's not a 9. Sudoku tells me that this is 1. Inside this column 5 needs to be here. So this is a 9, this is 5. Here I need 3 and 8. This is 1, by the way. And this is 9. So that this is also 9. That's the last place for a 9. This is from 4, 8. So that this is a 3. So we're almost there. This 3 now turns this into an 8. That's a 3. That's a 4. That's an 8. 4 here. 8 there. That's not a 4 because of this 4. So now 2, 6 here, 2, 6 here. This is 8. That's a 2. That's a 6. This is from 4, 8. And this is from 2, 4, 6. So now what is happening? What is happening is that 6 is not next to a 4. So that this can't be a 2. So we're left with 4, 6 pair here, which turns this into not a 4. And then what? Oh, this 5 here. This 7 here. Six here would be next to a 4. That doesn't work, so that's a 2. 4, 2, and this is the final step. What am I doing? That's 8, I think. Yes. 4, 6, 4, 8, 2, 6, 2, 4, 8, and 4, and that's it. Ooh, it was quite a ride. So no one said it was an easy puzzle, but it was all logical, as is always the case with puzzles by Richard Stolk, the professor. So this was harder than the average puzzle on the channel, but it's also fine to address such puzzles from time to time. And perhaps I should make a regular series with a Sudoku variant series now that Richard is publishing them on a weekly basis. But I'm not sure that I can keep up with this pace because I tend to procrastinate and all of that stuff. Anyway, thanks for watching this video. See you someday on SudoKanard.